Hello all, so welcome to the part 2 of TensorFlow Fundamentals. So in last lecture, we already discussed what tensor is, its physical meaning. So, and as promised, we'll now do the hands-on with TensorFlow. And so we'll create tensors and we'll thoroughly see what's the difference between scalar, vector, matrix, and then tensors, right? So oftentimes metrics and tensors are being confused and the terms are being used interchangeably, but this is not correct. And we'll see how much it is correct and how much it is not. So let's begin by importing TensorFlow STF firstly, and I'll just check the version. So you can just write TensorFlow underscore underscore version and then again underscore underscore, sorry, and you'll get 2.8. And yeah, I'll prefer anything about 2.7 will be good, right? So just importing TensorFlow STF and we are just check the version. Now let's create a scalar or a constant. So we'll start with the constant first and let me have this as a heading. So as we all know, scalar. So what if I'll ask, let me first create scalar and then I'll ask the question. So tf.constant is used to create a constant tensors. We'll see later how to create a variable tensors as well, but let's just write 24. So it's just a scalar 24, and 24 is my birth date, by the way, so I'm just writing it. So and we'll write just print it. So you can see there is no shape because it's a scalar, right? So a single scalar don't have shape. This might confuse you at first, but we'll see in the vector and then proceeding to matrix, we'll see how the shape is not there in this case of scalar. Some of you might say shape should be one, something like that, but it's not there. Then you can see clearly here we have data type, which is int32, and also you can experiment with float point o just I wrote, and you can see float 32. But for time being, let's proceed with integer and the corresponding numpy version. So if I will create a numpy array or a vector, then here we will get the corresponding numpy version of it, and it is good. Like in numpy we don't have all these three things at the same time, but in TensorFlow it is. So it's good, and also it's good that we have compatibility with NumPy and TensorFlow. Now, any guess with the number of dimensions? So if I'll say number of what is the dimension of a scalar? Any guess? Mostly you will be confused between 0 and 1, and let's take off the curtains. So here it is, it's 0, and it's good, like, because we already know that scalar has 0 dimensions, right? So those of you who have guessed that it has one dimension, no, it is not having a dimension, and this is nothing but the rank. So hopefully now you also know a little bit about the definition of the rank, that what does a rank represent in a matrix, right? We'll see. This is now just a scalar thing, so I should not use the word matrix, but I'll thoroughly explain the rank, don't worry. But let me just write right now that it is also the rank of the scalar, right? So let me just go to my board right now and just take fresh page. So we'll see that, let's say I'll write the scalar as 24. So it is nothing but a tensor. So scalar is also a tensor, but of rank 0. So what is rank? I'll come back to this after uh, creating a tensor, or what I can say after creating a vector, right? Because after that it will be more clear. So let's create vector now and a heading. Now let's create a vector. So again I'll use tf dot constant and this time a vector, so maybe 12 24, and let's just see what is it. So again you will get the shape this time 2 comma. It's good because we have two elements in the list, you can consider like that. And you can see numpy corresponding numpy array version of it. So you can compare both of this. Like here you can see it was just a scalar, now you're getting a array, right? So it's a vector, and again the data type, which is int32. Now any guess with the rank, or let me write number of dimension, and it's 1, of course. So hopefully now it's totally clear that what is the definition of rank, and if not, let's go there. So let me take a new color and then vector that we already created, which is 12, 24. So I'll give the formal definition of rank now. So rank is like, let's consider a first element. So how many x's are required to locate an element in an array, or in a vast sense, a tensor, is called rank of that tensor. So vector is also a tensor, but of rank 1, right? Because we need one axis to locate whether, so we will say that it is a zeroth index and it is one index. So we will need only one index, that is 0 or 1, right, to represent either 12 or 24 respectively. So this is called the rank. So I hope the rank definition is clear, and if not, it will be clear when we'll create now a matrix. So let's create a matrix now. So again, I'll proceed with the heading properly, and then we'll create a matrix. So again, I'll use kf.constant, and this time it's a matrix. So let me just write 12, 24, and 24, and let's write 36 and 48, if you don't mind. Just a table of 12, I guess, multiples of 12, and I hope I didn't mess with the brackets. Let's see. Yes, I didn't. So it's like 2 cross 2, the shape, as we all correctly guess. And again, the corresponding NumPy array version here, and again, the data type. So I think now it's clear that what should be the number of dimension, or I can say the rank of this matrix, and it's 2. So what we can say is that a matrix is a tensor with rank 2. And again, if I'll go here and write it for you, 12, 24, 36, and 48, and like this, then, or maybe this is more familiar term or more familiar representation in a notebook or in a paperback form. So I'll proceed with this. So again, consider an element 12, or any element you can consider. So how many axes or coordinates are required to locate? 2, right? Because zeroth row, or you can say first row and first column. So 2 indices are required to represent a single element or any element in this matrix, and that's why the rank is 2. So here it's a rank 2. So I'm not writing, but I'm just repeating that a matrix is a tensor with rank 2. Now let's create one more matrix. So it's not like I created 2 cross 2, so that's why it's rank 2. It's not like that. So let's clear out that confusion by creating this one more. So again, this time I'll just take 1, 2, 3, and probably 4, 5, 6. I hope I didn't mess with the brackets. And here we go. So it's like 2 comma 3 right now. So any guess for the rank, or to be precise, number of dimension? It's again 2. So it's not like if I'll create, so maybe I can also create, let me just replicate it here, or let me just try it here only with 7, 8, 9, and again it's 2. So it's not like if I'll create 3 cross 3, I'll get a rank as 3, right? So hopefully now the scalar, vector, and matrix things are clear. Now what I'll do is the most important part. Let's create a tensor. So it's a matrix of high dimension, you can consider like that, but it's called tensor now. And I want all of you to call tensor and get familiar with the tensors. So again, I'll create a tensor using tf.constant, but this time, please pay attention here that how I'm going to create. So brackets are really important here. So let's see how I'm going to do that. So firstly, I'm writing 1, comma 2, comma 3, and then I'm writing new brackets 4, comma 5, comma 6, and then what I'm doing is I'm enclosing it again with one more, correct? And then from here, I'm taking the last bracket, which is this bracket starts here. So I'm just taking the ending of that bracket with me. And then I'm creating one more. You can see, or maybe a space will be better to understand. Again, I'm just taking 4, comma 5, comma 6. And then I'll explain it how to write it in a better way, or in a way that you can't forget. So I'll explain that, but let me just write it 7, comma 8, comma 9. And always you have to take one bracket with you. That is the trick that I use, but you can use whatever you want. Again, I'm writing 7, comma 8, comma 9. You can choose any number, like it's not compulsion at all. And I'm writing now 10, comma 11, comma, sorry, 10, comma 11, comma 12. And we'll start with the bracket that ends here, and then this bracket is here, and we need one more for the starting of it. So you can see that this thing that I highlighted, consider the starting brackets as well. So from here and even the ending brackets, right? So this is one matrix that we created here, right? Or you can consider this one or this one, anyone, but the shape is here different as compared to it, like it's 2 rows and 3 columns, right? And we didn't create it, I guess, the matrix like that. So it's inside is a 2 row 3 column, so inside is 2 cross 3 matrix. Again, this is also one 2 cross 3, and again the last one is also a 2 cross 3 until here, right? This is the bracket. The last bracket, this one, is this one which is starting here, right? So what I have to say is that you can see there are 3 2 cross 3 matrix. 1, 2, 3, 2 cross 3. 2 cross 3 comes from here. You can see 2 rows. This is row number 1, and this is row number 2, and these are 3 columns. This is 1, 4, 2, 5, and 3, 6. So let me just print it and see if I am correct. Oh, it's not. There is something that I missed it. Oh yes, the comma here, I guess. Hopefully now it's okay, perfect. So you can see that there are 3, so you can read it like this: 3 2 cross 3 matrix, right? So this is a 1 2 cross 3, this is second one, 2 cross 3, this is third one. And if you can guess correctly, the rank will be will be let's see, 3, of course, because we need 3 axes or the 3 indices to represent this any particular element. So if you have to represent first element, let's say 1, then firstly we have to decide in which of these 3 our element is. So it's in the very first. So this the one axis or one indices that we have to decide to choose from this 1, 2, and 3. So from this 3, it's our one element is, or the very first element is in the very first, right? From this 3. And then inside we have 2 cross 3. So again, to represent a 1 and a 2 cross 3 matrix, we need one row and one column. So it's like first row, first column. So that's why in total we need 3 axes, and that's why the rank is 3. So this time I'm not explaining while going in the blackboard. but I think the things are clear now, right? So I'll want you to practice it, especially this thing. So what you have to do is you have to create a 2 cross 3 matrix, that we created here, right? A 2 cross 3, or you can just write with 2 cross 2 as well. So you have to just create this matrix, but you have to create this matrix like 3 times here. I'm just talking this one particular tensor. So, and you can go for higher dimensions as well. No one is stopping you, right? And in machine learning or in deep learning, we are gonna do the same. It's like we are going to have 1,000 dimension, like 1,000 images, and each image will be of, let's say, 224 comma 224, right? Height and width. So that will be a tensor of 1,000 comma 224 comma 224, right? And the same thing can be applied to other things as well, right? Because in deep learning, what we do, or in machine learning, what we do is that we create tensors, or the numerical representation of all the data, or whether it's an image data or a text data, anything that we have, we create a tensor or a numerical representation, because deep learning or machine learning is nothing but a mathematics, and we need numbers in order to be given as an input to our machine learning or deep learning models. And that's why tensors are really, really useful, right? So I hope things are clear now, and we'll see in very next video. So thank you and bye bye.